All right, I'm gonna start here by doing an example just with you because I didn't do some that had some polyatomic ions, and I just want to show you how you can do these. So again, we're gonna be balancing. The first thing we do is draw that line. I've already done that. And then we want to tally up all of the elements. So one thing to note here, I guess this isn't a good one, but we'll do this one and then we'll probably have to do another one. One thing to note is that some of these things are polyatomic ions, and if you remember what those are, they're basically more than one element together that have a charge. And we had those on our polyatomic ion sheet. I don't know if I can find that here, but basically you should have this sheet that has a whole bunch of different ions that are more than one element put together, and they have a charge. So if we can pick those out in our reaction, then sometimes we don't have to actually split them into the elements like I have in the past. So before I would write down H, Cl, Ca, O, and then H. But OH is actually a polyatomic ion. So if we want to keep that together, we can, but only if it's OH on the other side. And it is actually OH on the other side, but this one is a hard one to see that, mostly because this is H2O, so that's one H and an OH. It's literally just how we would write it. So it's not written like that, so let's just do it the regular way, and I'll show you later how you don't actually have to split it apart. In this case, we will split it, so that's all of our elements. Then we got H, Cl, Ca, O, and I don't need another H. All right, so that's all of the elements. Let's tally up what we got here. So on our first side, we got how many H's? We've got an H here, and we've got an H there, and this 2 is saying there's 2 of everything inside the brackets. So on that side, we actually have 3 H's. Okay. Moving on to Cl's, we got 1 there, and that's it. There's no numbers below or above, so it's just 1. For Ca, again, same thing. We've only got Ca right here. There's no numbers in front or below. This 2 is only going to the stuff in the brackets. Ca is not in the brackets, so it doesn't count towards that, so we just have 1. And our oxygen, it's inside those brackets. Oops. So because it's inside the brackets, that 2 goes to that O, so we do have 2 O's. Okay, so that's how we tally up that side. I'll try and keep those colors going as they go across. So for H's, here we've got 2, right? And there's no other ones. So for here we've got 2. Remember that little 2 below is telling us how many H's we have. For Cl's, this is our Cl, and we've got another number 2 below it, so that's 2 Cl's. For Ca, there's no number below it, just the Ca on its own, so that means 1. And then our last one is oxygen. That one I have is green. There's no number in front or below, so that would be a 1. Some people might think that this 2 goes to the oxygen, but remember that those little subscripts, those numbers below, those are referring to the element in front of it. So in front of the number is the element that's 2, not behind the number comes after the letter, not before. All right, so that is that. So now we have it all tallied up. I'm not sure why I didn't write 2 right here. So now we've got to balance it. So A rule of thumb, I'm gonna tell you. I'll just write that maybe right here. So a rule to follow is balance H's and O's at end. So normally the hydrogens and oxygens are going to be the things you balance last, okay? So that means let's balance the CAs and the CLs. Metals I normally balance first. Well, the metals are actually already balanced here. Ca is balanced, so we don't need to worry about that. Our next one that we want to do is Cl. So Cl is not balanced. It's got 2 on the right and only 1 on the left. So let me just highlight that there for us. So we need to get 2 on the left-hand side right here because we have 2 over here. So what I'm going to do is put a number 2 in front, and that's going to change my 1 to a 2. Okay, but what that also is going to do is it's going to change this hydrogen to 2. So now we've got 2 hydrogens here and we've got 2 here. So that changes our hydrogens to 4. All right, which is fine. Let's go for balancing our hydrogens right now. Because when we balance it out, it's actually going to work out perfectly. So let's balance our hydrogens. Our hydrogens are 4 on the left and 2 on the right. To get 4 on this side, we need to put a 2 here. So 2 times 2 gives us 4. And then by doing that, we put a 2 in front of the H2O, so that says 2 oxygens as well, which makes this a 2, which then in turn makes it balanced. Okay. So balanced, it would be 2 and then 1, 2 and then 1. All right. So that's how we would balance that. Hopefully the colors don't mess you up, and I hope it helps to highlight sort of what's going on there, but I like to use colors to keep my attention on what's going on. Okay. Let's do another one. Just got to go back to that page because there's some that are, yeah, let's do number 4. I like this one just because it's a good example for what I was trying to explain to you earlier, but I picked a bad example. So for this one, we've got Cu plus AgNO3 gives us CuNO3 2 plus silver. All right, so here we've got something that I was telling you before, is that we have polyatomic ions on both sides. So our first job is to draw that line down the middle because we are balancing it one thing to the next. Then we want to tally up all the things that we have. We got Cu, we got Ag, and this is what I told you before. You could put N and O, but because NO3 is here and NO3 is here, they're actually on both sides, so we can just balance NO3 together. We don't need to separate it into its nitrogens and oxygens. We can just write NO3. So like 90% of the time, we're just going to be writing elements here. So these are just different elements. And then some of the time, we're going to be writing these. So instead of me saying balance the elements, a lot of the times we could be balancing the ions. And in this case, that's what we're going to do. So we got Cu, we got Ag, and we got NO3. I don't know why this is skipping. All right, so let's do this. We got CU on the left-hand side, no numbers in front, none below is 1. AG right here, no numbers in front or below is 1 as well. And NO3, some people might get confused and put the 3 there. What's going on? So you're not going to put that 3. That 3 goes with the NO3, so there's only 1 of them. On this side, we've got 1 because there's no numbers in front or below, as well as AG, there's no numbers in front or below. And for NO3, there is a number below, that is 2. Okay. So now we can balance it out. Everything's balanced except for our NO3s. So if our NO3s are not balanced, then we're going to need to balance those. We've got 2 on the right and 1 on the left. So we need to get 2 on the left. To do that, we can only put numbers in front. So we put a 2 there. That changes 2 times AG and 2 times NO3. So that changes both of those things, okay? Because they're connected together. They're a molecule, so we're just saying there's 2 of that molecule now. So that will balance it out. But now that messes up our AGs. Our AGs are 2 on the left and 1 on the right, so we need to get 2 on the right. If we put a 2 there, it balances out our AGs, and now we are balanced. We've already got the coppers balanced, so we are good to go. So coppers are good. NO3s are good because that 2 is going to it, and then our AGs are good. Okay, so that is how you balance that. I'm going to go back to, so those are some examples for you. I'm just going to finish off this PowerPoint here. So this is on writing chemical equations. It says chemical equations can be written in 2 formats, word equations or skeleton. So far we've been looking at skeleton equations where you're basically writing out the chemical formula. So we got Na, that's our elements from our periodic table. That's how we would write that. That's what we've been doing so far, but you can also write it in words. So we could say sodium, which is Na. Plus chlorine gas is equal to sodium chloride. All right, so that is something that we can do. And we're going to practice that out by doing some of these. I did this earlier and I forgot to. I didn't record it properly, so redoing it. So we use the following word equations to write and balance the correct skeleton equation. Don't forget the rules for naming ionic and molecular. I'm going to take all of this to a note because we are going to have to balance, so we're going to need some space. So whenever you're doing this out, you might want to do it on paper. Well, I would definitely suggest you do it on paper. I hope that's enough space. All right. I don't know if this is why this is not working. I guess I can't write in the middle of words. Maybe not. Yeah, I can't write in the middle of words. Perfect. Lovely apple. Just let me bring this back up so that we can see. Sorry, guys. All right, let's do the first one there. It says hydrogen gas reacts with oxygen gas to produce liquid water. So our first job is to figure out what the symbol is for hydrogen. And I hope you know already that it's H. You might not, you may, I'm not sure. Something to also note is that on the periodic table, when we were in class, I told you this, that the elements that are from nitrogen, oxygen, fluorine, chlorine, bromine, iodine, that 7, 8, 9, 17, 35, 53, and also hydrogen, those are something called diatomic molecules. And diatomic means that they never exist on their own. So they'll always exist as H2. Okay, so when we say hydrogen gas, you don't just write H, you write H2. Another one that is a diatomic is oxygen. So we don't write oxygen by itself, we write O2. There's an arrow, and it produces liquid water. Hopefully you know water is H2O. It does say liquid there. I should be writing the states of matter. So G is for gas, L is for liquid, and S is for solid. So this is what, if we react those two, that's what it creates. So let's figure this out. Check to make sure it's balanced. It's not. So you need to balance it. So just like we've been doing so far, we've got to tally up the elements we have on each side and then balance it out. Hydrogen has 2 and oxygen has 2. Hydrogen has 2 and oxygen has 1. Don't know. Okay, so that's that. So now we need to balance our oxygen. So our oxygen is 1 on the right-hand side, so we need to get 2 there. So to put a 2 there, we would, if we put a 2 in front of there, that'll change our oxygen to 2. But it'll also change our hydrogen. 2 times 2 right there will give us 4. Okay, so whenever you're adding that number in the front, it's also going to go to the other elements that are there. Now our oxygens are balanced, but our hydrogens aren't. If we want to get 4 hydrogens on the left-hand side, what we've got to do is put a number in front. So we got to look at this small number and be like, 2 times what gives us 4? And hopefully your answer is 2. 2 times 2 gives us 4. So that would balance out that hydrogen. So now our oxygens and our hydrogens are balanced and we are good to go. So that's going from words to elements, or the skeleton formula as they say. All right, that's number 1. I'm going to try number 4 here, and then I will leave you to try these on your own. Number 4 says aqueous cobalt 3 nitrate. So aqueous, I guess, is another state of matter I didn't go over. So we got solid, liquid, gas, and aqueous. Aqueous means it's something dissolved in water. This is a gas, this is a liquid, and this is a solid. All right, so let's do this one, cobalt. We got to look up on our periodic table what cobalt is. I'm gonna go back to these pictures. Cobalt is in the transition metals. It's number 27 and it's CO. Because it's in the transition metals, we don't know its charge, but we do because it tells us in the question that it's 3. See the Roman numerals there? So we're going to write CO, and then I'm going to write a +3. It's connected to nitrate. Nitrate, remember that 8 ending is not on the periodic table, so we're never going to find nitrate no matter how much you look. Where we got to find nitrate is in here. So if we look for nitrate on here, we should be able to find it. It's right here. It's NO3 with a -1 charge. So O3 with a -1. Notice that this molecule is not balanced, so we need to balance it. So just by doing that whale or that crossover, we're going to put the 3 down here and the 1 down here. That's going to be CO and O3. I'm not sure why this is messing up on me, and that's not how you do it. I got ahead of myself. And O3, and then because there's a 3 that's coming down here, this would be 3. All right, so that's cobalt-3 nitrate reacts with solid zinc. So it's going to react with solid zinc. If you look on the periodic table, zinc is Zn. So it's going to react with that. What does it create? Well, it probably creates cobalt and zinc nitrate, I'm going to guess. Yes. So this is a type of reaction that we haven't gone over yet, but you can predict what it's going to be. I don't know why. Technology hates me. I just want to zoom this in. Anyway, so we've got cobalt by itself, and we've got ZnNO3. Zn is on the periodic table, and it has a +2 charge. If you don't know that, you can look it up. But because that's a +2, this is a -1. It's not balanced. So just like I did over here, I can do this up here, Zn +2 and O3 -1. We got to do that crossover. So in doing that, this becomes a 2 there. So this 2 comes down right there. The 1, we don't need to put it there. You could if you wanted, but that's that. And they said it was solid cobalt and aqueous, I believe. I'll double check. Aqueous zinc nitrate. Perfect. So this is how you would write that formula. So a lot of things going into this. This is why it's really important that we understand how to name. This is naming right here, in order to be able to do all this. Okay. So that is how we do those topics. Please let me know if you need anything, but that's topic 6 in a nutshell. All right. Have a great one, and we'll finish topic 7 this week for sure. I'll start that tomorrow.